Hello everyone, welcome back to our class. Let's continue study chapter 9, convection. In this section, we will study nature convection. As stated previously, the heat transfer by free or nature convection is due to the difference in density in the fluid. In free convection, the heat transfer depends on the coefficient cubic expansion, beta, which is given by rho 1 equals rho 2 times 1 plus beta times T. T is temperature difference. Beta is expansion coefficient. We use this equation to calculate the density difference, density change. So density difference rho 1 minus rho 2 equals rho 2 beta delta T. The upthrust per unit volume of fluid is rho 1 minus rho 2 times gravity G. The nature convection depends on the density difference times G also equals rho beta delta T G. This equation drive the free convection. Okay, the first section, nature convection equations. Nature convection is derived by the density difference we know. The boundary layer on the vertical flat plate is similar to the flow across a flat plate. Also has laminar flow or turbulent flow. Can separate two regions or three regions. One is laminar flow region. Another one is turbulent flow region. Maybe in the middle there is a transition region. So three regions. For a vertical plate, at the beginning, in this region is laminar flow region. In this region is transitional region. This part is turbulent flow. Very similar to the flat plate. In the nature convection, there is another very similar to the Reynolds number. There we use another number, is Grashof number, to express the flow rate, flow mode. Consider the cubic expansion coefficient and gravity. We use the same way of the dimensional analysis to obtain the Grashof number. Here, I just give the number calculation equation. Grashof number equals beta G delta T L power third over mu power second. This equation to calculate the Grashof number. Grashof number is the ratio upthrust force and viscosity force, different force. Beta expansion coefficient. G is gravity. Delta T is Tw minus Tf is the temperature difference. L is the characteristic length. Here mu or gamma mu is viscosity. In the free convection, upthrust force is the main factor to drive the flow. So the function and the status of Grashof is similar to Reynolds number. But here there is another coefficient is beta. For ideal gas, beta equals 1 over T. T is absolute temperature. The last page, the temperature difference, we use the Celsius difference to calculate is same, but capital T is absolute temperature. So beta is called as expansion coefficient. Beta G delta T corresponds to the uplift force produced by temperature difference. Temperature difference produces the density difference. With the same way for free convection, we also obtained very similar equation. Nusselt number equals Grashof number and Planck number the function. So it is F GR PR is the function. So Nusselt number, we use this equation to calculate. That's to say, if we know Nusselt number, we certainly can obtain the H. If we obtain H coefficient, heat transfer coefficient, certainly we can use the Newton's cooling law, the equation to calculate the heat transfer flow rate. Okay, how to calculate the free convection, the heat transfer flow rate? So we can use the relationships to calculate the coefficient through Nusselt number. Nusselt number is equals C Reynolds number power m, Grashof number power n, Planck number power s. Reynolds number for convection, for forced convection. Grashof number for free convection. Planck number is the flow, only relation to the working fluid. So parameter C, M, N, S can be determined by experiments. Therefore, the relationship can be called experiential equation. This is most general ways to calculate the heat transfer in convection. For vertical flat plate in a very big space, vertical plate, we use Nusselt number equals C Rm G power n Planck power s to calculate. Subscript m means the average temperature of fluid and wall. Most cases we use the mean temperature. C and S is a constant from experiment. Determines different case. We obtain the different numbers. For laminar flow, we use C equals 0.54, N equals 1/4, Grashof number, Planck number together times. In this region, we think the flow is laminar flow. If the region in this region, C is equals 0.15, N equals 1/3. Also, Grashof number times Planck number, the number is in this region, we think the flow mode is turbulent flow. Characteristic length L is the ratio of area, the body area, and body parameter. Because sometimes the body is very special, the shape. It is not ball, maybe it's very special, complex shape. In this case, the L is the ratio of area and the parameter. For circular dish, L is 0.9 times D. Thank you.